Okay, this video is going to explore Ray Kurzweil and the singularity. So, what Ray Kurzweil says is basically that we're headed towards a technological and evolutionary singularity, where life will actually evolve from carbon-based uh, life forms to, I guess, silicone and whatever else, whatever other, I guess you could say, technological, non-inorganic life forms that are going to be. And basically, technology is the next species, I guess you could say, or form of life. I guess that would be a better way to explain it. So, I mean, obviously, there's a few things that come to mind. First of all, wait a second. Technology doesn't evolve. It's just we create it. We evolve it artificially, so to speak. But well, yeah, that's true. But we're getting to the point now, technologically speaking, where we can begin to let technology self-replicate. It's almost at the point where technology can replicate itself. And now I can name a few things. The first that comes to mind is nanotechnology. It's almost a cellular level of reproduction that we're working on. And this has both medical and I guess computer related I guess you could say implications, because not only could it help attack cancer cells or be used as viruses very dangerously, but it could also theoretically start to create the first organisms that don't rely on um, organic compounds, which is pretty amazing in itself. Um, Artificial intelligence is a little bit far off into the future, but at the rate that we're developing technology, it's safe to say that in 20 years or 30 years we're going to have intelligent machines. Now, I've noticed there's a lot of opposition to these ideas. They call the people who support the singularity to be idealists and almost religious in a technological sense, and I'm sure it can be taken that way. But if you look at the trends and how technology is going, this sort of seems like the direction we're headed, whether we like it or not. Now, the question of whether it's going to be a utopia for humans or not is, I mean, I'm sort of trying to be a realist about this. Of course, it's not going to be a utopia for human beings. There's going to be horrors. There's going to be, I think, if we implement technology into our organism to replace our parts, to replace kidneys and hearts and brain cells eventually, and eyes and ears, I mean, of course, then all of a sudden a computer virus is going to apply to humans. So there are a lot of good things and bad things that I could say are going to happen. But I think that's with any kind of form of evolution. I mean, with any kind of new improvement or a new unfolding of evolution, there's always going to be a downside to the new forms that arise. So, in the next century, as technology's been evolving, we've had the atomic bomb and we've had nuclear energy. We've had um, basically biological warfare has begun to emerge, but it's also helped us understand a lot of things about human biology and chemistry. And so, with any new wave of a new form of technology, there's new forms of good and bad. It's neutral and it's used for both. Now, there's more horrors now, technologically speaking, than there used to be, but relatively speaking, we seem to reach new plateaus with new technology, and whether it's the printing press or the internet, the atomic bomb, or the first cannonball technology. I mean, there's good and bad implications, and it sort of has this yin yang thing going on. There's this neutral technology that's invented, and it's more developed in the former, and it has good and bad implications for each new generation of technology, and it seems to be evolving over time. The only thing that we can say, now, and a lot of people also argue, the second point is a lot of people argue with Kurzweil and say, well, look, you know, there is no singularity coming, there's no direction of evolution, you're being too idealistic, but retrospectively we can look at the direction that we've been taking, and there are a few interesting things that pop up no matter what you believe and how you choose to interpret it. The first is that evolution is happening at a faster rate, and it's happening. The new species tend to be more complex, so this can be observed when you look at how fast human beings evolved, or mammals evolved, versus how fast dinosaurs evolved. Yes, there are different conditions now, but the speed and rate at which evolution can take its course is improving. So you can almost say that evolution, just as DNA evolved from RNA, a more basic form. At least this is a theory I think that's pretty much staple in evolutionary science. But just as RNA evolved and became DNA eventually, 1 to 2 strands, so too has technology and a new species been evolving faster and better. I mean, this is at the very beginning. And it took a couple, what is it, a billion years? Less? I don't know. But at any rate, it took a long time for single-celled organisms to become multicellular organisms. But when they did, it was an explosion. The Cambrian explosion is the first real wave of complex life that emerged on Earth. And this, even though by today's standards took a long time, if you look at the broader picture, it was, relatively amazing that this was able to happen. And the future generations, future species, such as reptiles evolving into dinosaurs and then reaching their maximum, what's it called? Their maximum size, basically the peak of dinosaur evolution, I guess you could say they were growing exponentially. The rate at which something grows exponentially has been speeding up, and each new exponential growth is more complex than the former. And if you look at throughout all of evolutionary biology, and it's true. This is a strange phenomenon. Now, I think there are probably a few ways to interpret that phenomenon, but one of the ways is to say that somehow evolution is becoming more complex over time, and it's happening faster over time. It took a lot less time for mammals to reach their peak, I guess you could say, size and weight and height, than it took dinosaurs. It took a vastly smaller amount of time for them to do that, and humans even more so. So this is a strange phenomenon, and life now is more complex than it used to be back then, way back in the day. I mean, and if you could actually see the sort of a holistic development, transcend and include, as Wilbur might say, in the hard sciences, in evolutionary biology. I mean, our brains aren't just mammalian brains; they're also reptilian. So it's not that we abandon the former species to include the latter. We sort of somehow take what one species had and develop it to a new form, and we kind of base our the sort of like the building blocks. So the reptilian brainstem is the building blocks of the mammalian one, and it's not that the reptilian brainstem would develop the mammalian one, but it's almost safe to say that the reptilian brainstem would develop a more complex brain, which happened to be the mammalian one. So evolution isn't necessarily linear; it's definitely nonlinear, but it's exponential. And the only direction it has is to become more complex. Why? Well, there are many theories. There are theories that say, look, evolutionary speaking, you can see this like single-celled organisms began to develop. The ones that seemed to work and survived through natural selection were the ones that could mutate the most rapidly and most efficiently. So the ones that were mutating were the ones that were surviving, and out of those mutations, there are a few traits that worked. One of the traits that worked in the beginning was the ability to become more complex. Maybe that was one mutation. But that mutation enabled this life to survive and have an advantage over other life forms. So that complexity is the driving force of evolution through natural selection, that all species have used. And that's one of the very, very, very ancient so to speak, technologies that evolution, DNA, has developed, the ability to become more complex over time. And that's something all species share. Now, there's conjecture saying, look, some species don't evolve more complex over time. We still have fish and amphibians. Yes, I don't think that all species would tend to do this. I think there would be some degree of variation and some niches that some species would remain in. And I'll continue in part 2.